In this video, we'll be learning about finite sets using the roster method and ellipses. So let's start off with this first problem. Write the set and roster method of prime numbers greater than 10 and less than 50 and label it with a capital P. Include an ellipsis. So our set name is going to be set P. And our elements in our set are going to be prime numbers greater than 10 and less than 50. And we have to include an ellipsis. So an ellipsis is a way to summarize a set or summarize a pattern. So for example, if I wanted to write all numbers in between 1 and 100, that would take me a good while. But a way I can summarize it is I can say 1, 2, and 3. So I have to write down 3 numbers to establish a pattern. And then I can use the ellipsis here, which are these 3 little dots. Now you're not supposed to put a comma after the third number. I don't know why I did that. But you put 3 dots, which that's what the ellipsis is. And then you put the final number if it reaches a final number. So in this case, I want it to be 1 to 100, so I'd include 100 at the end. This way, I don't have to write out all the numbers in between 1 and 100. I showed a pattern and I summarized the whole set. Now, we need to include prime numbers in our set that are greater than 10 and less than 50. So it's not including 10 or 50, because if it did, it would say numbers greater than or equal to 10 or less than or equal to 50, but there's no equal to part, so we're not going to include 10 or 50 in our set. Now, a prime number is a number that has 2 different factors, and only 2 different factors. And these 2 different factors you can divide the original number by, and you'll get a whole number back. So for example, let's do a number that is prime. So we'll do 3. Now this is an example. This is not going to be in our set. So 3 has 2 different factors. It's going to be 1 and the number itself, which is 3. Now you can't break down 3 any further. And if I would divide 3 by 1, I would get 3. And if I divided 3 by 3, I would get 1. So those are 2 whole numbers. So that means that 3 is a prime number. But if I did a number like 4, you write out 1 in the number itself, which is 4. But you can also divide 4 by 2. And 4 you can factor out to 2 times 2. So you can divide 4 by 1, which is going to give you 4. You can divide 4 by 4, which is going to give you 1. And if you divide 4 by 2, you're going to get 2. So you get 3 different numbers that you can divide 4 by to get a whole number back. So it has more than 2 factors, and it doesn't have exactly 2 factors, so therefore 4 is not a prime number. Now, we're going to start off with our first number, 11. So in our set, 11 is the first number we're going to have, because remember, we're not including 10 in our set. So we're going to see if 11 is a prime number. So we have 1 in the number itself, which is 11. And we can't break down 11 any further. So therefore, 11 is going to be our first number in our set. Next, we have 12. Now we have 1 in the number itself. But 12 you can break down into 2 times 6 or just 3 times 4. So we have more than 2 factors. So therefore, 12 is not a prime number. Now we can move to 13. And we have 1 in the number itself, and 13 we can't factor out. And the 13 only has 2 factors, so therefore 13 is a prime number. Next we have 14, so we have 1 times 14, but 14 we can factor out to 2 times 7, so it has more than 2 factors, so 14 is not going to be a prime number. Next we have 15, so we have 1 in the number itself, but 15 we can factor out into 3 times 5, so 15 is not going to be a prime number. Next we have 16, so we have 1 times 16, but we can factor 16 into 2 times 8. So 16 is not a prime number. Next we have 17, so we have 1 times 17, but we can't factor out 17 any further. So 17 is going to be our third number. Now that we have 3 numbers, and we've established a pattern, we can use our ellipses. or ellipses, sorry. Now we need to find the last number of the set. So the number is, we're going to, instead of starting from the number after 10 in our set, we're going to start from the number before 50. So in that case, it would be 49. So let's see if 49 is a prime number. So 49, we have 1 in the number itself. But 49 you can factor out into 7 times 7. So 49 is not a prime number. Next we have 48. So we have 1 in the number itself. But 48 you can factor into 2 times 24. So 48 is not a prime number. Our next number is going to be 47, which 47 we have 1 in the number itself, which is 47, and we can't factor out 47 anymore. So 47 is going to be our last number in our set. And then we close our set. So that's going to be your answer. So for the second problem, it says write the set and roster method of even numbers less than 20 and greater than 0 and label it with a capital E. Include an ellipsis. So our set name is going to be set E, and it's going to contain even numbers less than 20 and greater than 0. So it's going to be in between 0 and 20, but we're not going to include 0 and 20 because we have no equal to than part of the set. So we're going to include, our first number is going to be 1 and our last number is going to be 19. So we need to determine if those numbers are even. So an even number is a number you can divide by 2 and you get a whole number back. So for example, let's do a number like 22. This is not going to be in our set, by the way. So if we divide 22 by 2, we're going to get 11. So since we got a whole number back, this means 22 is even. But if we do a number like 23 and we divide it by 2, we're going to get 11.5, or just 23 halves. So we don't get a whole number back. So this means 23 is not even. So we start off with 1. 1 is going to be our first number. If you divide 1 by 2, we're going to get 0.5. So that means that 1 is not an even number since we didn't get a whole number back. Now we go with 2, which is our next number. We divide 2 by 2. We're going to get 1. And that's a whole number. So that means that 2 is even. So our first number in our set is going to be 2. And then next we would do 3 divided by 2, and we're going to get 1.5, which that's not a whole number. It has a half. So since it's not a whole number, it means 3 is not even. If we do 4 divided by 2, we're going to get 2, which that is an even number. I'm sorry, that's a whole number. So that means that 4 is even. So 4 is going to be our next number in our set. And then you can see a pattern. You have to go up 2 numbers to get the next even number. So our next even number would be 6. And then once we have our 3 numbers indicating a pattern, we can use our ellipsis now. So we put our 3 dots, and now we need to determine what's the last even number in the set. So we start off with 19. That's going to be our last number. But 19 is not an even number, so we have to go to 18. But 18 is an even number. So 18 is going to be after our ellipsis. And then we close our set, and that's going to be your answer.